Hello, pre-algebra class. Welcome to another edition of Mr. Chow Time. Look at this thing I learned how to do. I can be this size, I can be smaller, I can do this. Yeah? You guys like that? Okay. Enough messing around. Or is it? Is it enough? Apparently it's not, because I can't go to the next slide. Here we go. Proportional and non-proportional relationships, lesson 5. Is that right? On page 206. All right. So let's start actually with the second one, proportional. This is the main idea. Proportional is when two quantities have the same ratio when simplified. So for example, 2/3 and 4/6 are equal to each other. That means that they are proportional. The constant of the ratio is the y over the x. The y is the top number and the x is the bottom number. So here in this case, y is that number and x is this number. So 2 divided by 3 equals, I'm just going to do this. 2 divided by 3 equals 0.6 repeating. So that means k, the constant of proportionality, is 0.6 repeating. Or 2/3. What's the constant of proportionality of 4/6? Well, it's 2/3, or 0.6 repeating. So 2/3 and 4/6 both have a constant of proportionality of 0.6 repeating. And because they have the same constant of proportionality, that means that they are proportional. And that's what this basically means here. Constant, ratio, or rate. Okay. Any relationship that is not proportional is called non-proportional. It's a relationship in which the ratios or rates are not constant. And we'll look at some of those later. Okay. Let's take a look at our first example. Determine whether the cost of coffee is proportional to the number of pounds. If the relationship is proportional, identify the constant of proportionality. Explain your reasoning. So first, we need to talk about the idea of the independent and the dependent variable in these relationships. And because that tells you which number goes on top, which one is the numerator, and which one is the denominator. So let's look at these. Does the pounds depend on the NTs, or the NT depend on the pounds? So does the amount of money that it costs depend on how many pounds you buy, or does how many pounds you buy depend on the total cost? And when you look at it like that, you should be able to see that cost depends on how much you buy. How many pounds you buy, right? So if cost depends on how many pounds you buy, then the cost is the dependent. Dependent. It depends. Which means that the coffee, the number of pounds that you buy, this is the independent. So, now that you know that, the independent variable is always the x. Independent. Oh, I forgot about my face. My face. It's... Oops. Oh no. All kinds of things are happening that I don't want to happen. Okay, I'll just use the mouse. Sorry. I'll just shrink me down here. There we go. Cost depends on how many pounds you buy. Sorry about that. Okay. So the independent variable goes on the x-axis. When you look at a coordinate plane, the x is the independent and the y is the dependent. The independent, what's a good way to remember this? I don't know, actually. I just know that x is the independent. Okay, so independent then is x, cost is y. And remember, y goes on top, x goes on bottom, right? Remember that from the previous slide here? Hopefully, it's right here. K equals y over x. Okay. So y then is the cost, which will be 3, and then the number of pounds is 1. 6 over 2, 9 over 3, 12 over 4. So the constant of proportionality for each of these is 3. And because they all have the same constant of proportionality, that means the relationship is proportional. So I would just write, if I was writing the answer here, I would write the relationship is proportional. And then the constant of proportionality, k, equals 3. And then my reasoning would be that all of the y values divided by all of the x values equals 3. Okay. Also, all of these ratios are equal to each other. Okay. Your turn. Determine if the number of legs is proportional to the number of 7th graders. So the number of 7th graders have a proportional relationship with the total number of legs that they have. Which one is the independent? Which one is the dependent? Go. Welcome back. The number of 7th graders is independent. The number of legs is the dependent. So 1 over 2, 2 over 4, 3 over 6, 4 over 7. If you divide each of these, or if you just reduce them all, 1 over 2 is reduced to 1 over 2, 2 over 4 is reduced to 1 over 2, 3 over 6 is reduced to 1 over 2, 4 over 7 cannot be reduced, so this is not proportional. There's no constant of proportionality. Therefore, this is not a proportional relationship. All of these ratios do not equal each other because of this one. And that is the reasoning. Okay. Determine whether the distance is proportional to the time traveled. So which one depends on which? Well, time is always x. There's never really an instance where time depends on something else. Time just goes on with or without you. And so anytime that you see time, you can always rely on that one being x. Distance relies on how much time you've traveled. So 50 over 1, 70 over 2, 90 over 3. And you should be able to see that the constant of proportionality is not the same. Right? So There is no constant of proportionality, or there is, for each ratio there is, and they're not the same, which means that there's no proportional relationship. I can say it. Okay. Your turn. Determine whether the number of watches is proportional to the number of wrists. Welcome back. Okay, so which one depends on which one here? This is a little bit trickier to know. Do the wrists depend on the watches? Probably not, right? Watches probably depends on wrists. So 6 over 1, 14 over 2. This is equal to 6. This is equal to 7. 22 over 3, which is just reduced to 22 over 3. So each one of these, the constant of proportionality is not equal, not a proportional relationship. Okay. But why, Mr. Chow? Why are we doing this? Well, proportional relationships can often be used to describe real-life situations. In fact, all of these that we've looked at have been real-life situations, right? And we can use an equation to describe the situation. Y equals kx. And this is just the equation that we were looking at earlier, k equals y over x, but we've solved it for y, which means we've multiplied by x on both sides to get y equals k times x. When we solve for a letter, that means that we're trying to get that letter by itself. So if we're solving for y, we're trying to get y by itself, which is what we ended up here. So with this relationship, or with this equation, y equals kx, we can do some of the work in trying to figure out if a relationship is proportional. And we can also use this relationship to figure out things that we know are proportional. So for example, a circle's circumference. Circumference is the distance around the outside, right? It's like the perimeter of a circle. It's called a circumference. It is proportional to its diameter. The circumference is proportional to the diameter. Use the figure to find the constant of proportionality. Then write an equation, relation, right? I wrote something here wrong. That relates the circumference. That's what this is supposed to say, relates. The circumference of the circle to its diameter. What is the circumference of a circle with a 6-inch diameter? So, we know that this circle has a diameter of 4 meters, and the circumference is 12.56 meters. And we want to find out what is the circumference of a circle with a 6-inch diameter. 6-inch instead of 4 meters? Did I do this wrong? I might have to go back and change the units. No, actually, it's fine. Okay. So, in this relationship between circumference and diameter, circumference depends on the diameter. So circumference would be on top and diameter would be on bottom. And this would equal k, right? Well, the circumference is 12.56. We divide that by 4. And this equals 3.14, and so on and so forth. This actually goes on forever, right? Because this is the number pi. So this is our k. Well, if we rewrote this equation, c over d equals k, but we solved it for c, because that's what we want to know, right? What is the circumference? Then we would multiply by d on both sides and get, c equals kd, which is essentially what we did earlier, y equals kx. right? Because this is y and this is x. So if we did that, we can come down here with this new circumference, 6 inches, right? That would be 6 equals 3.14 times our diameter. Oh, we know the diameter. Sorry, this is a 6-inch diameter, not a 6-inch circumference. We want to find the circumference. And so it's whatever 3.14 times 6 is. That's our circumference. 6 times 3.14 equals 18.84 is C. Okay, so I hope I did not confuse you there. When I'm writing this equation, I wanted to find the circumference. So that was the C, which we found over here, right? Circumference equals 3.14, which is our constant in proportionality, which we solved right here. This is our K. And we're multiplying that by our new diameter. And so if we had any diameter, we could just multiply that by our constant of proportionality, and which is pi, and we would find the circumference. Okay. Your turn. The cost for 2.5 kilograms of donkey meat is $720. So find the constant of proportionality. Then write an equation relating the cost to the kilograms. How much will 4 kilograms cost? Welcome back. Okay, so here we have cost, and then we have the amount of meat, which is in kilograms, right? So the cost is going to depend on the amount of kilograms. So this is the independent, which is the X, and this is the Y, right? So the cost is $720, and the amount of donkey meat we get for that is 2.5 kilograms. So if we take $720 and we divide by 2.5, then we get our constant of proportionality, right? So this is 5. Oh, I think we need to get rid of this donkey picture. We just maybe need to move it over just to give ourselves a little bit more room. Come over here. All right. Which is 720 over 5 over 4, which is the same thing as 720 divided by 5 over 4, which is the same thing as 720 times 4 over 5. Now 720 and 5 could be reduced, right? And that would be 144 over 1. So it's 144 times 4, which is 576. That is our constant of proportionality. So now that we have our K, we can write an equation relating the cost to the number of kilograms, right? So the cost is our C or our Y. Let's just use the letter Y because we're already using Y and X, right? So our Y is going to be equal to 576 times X. So if we put X as 4, which is what the final part of the question is asking us, how much is 4 kilograms? We just put 4 into X, right? Because X is our amount of meat. We can find it for any amount of meat now, right? So 576 times 4 equals Y. And what is that? 576 times 4 is 2,304. If you wanted to buy 4 kilograms of donkey meat, that's how much that would be. But, you know, the donkey doesn't want to be eaten. It's saying so right there. Okay. Thanks. Have a good night.